Good morning, or good afternoon, or good evening, wherever you are in the world. Let me introduce myself. I used to work at Google. Then I ran a startup, Future Cam. I then worked as CTO of a startup. I now work as a part-time CTO with multiple companies. Today I wanted to talk about refactoring. What is refactoring? Refactoring is changing the structure of the code without changing its behavior. When you refactor code, it doesn't get a new feature. It doesn't have a better UX. It doesn't change in any way that users notice. In fact, if you're refactoring and users have noticed it, it means you did something wrong. It's just changing the internal details. It's like taking your car for your annual servicing. The performance of the car is still the same most of the time, right? Internally, things have been cleaned and so on, but you don't know. The car drives the same way. Refactoring is like that. And I believe refactoring is one of the critical tools in our arsenal to have good code quality. If you're not refactoring your code, you have bad code. That's my point of view. Some people say that we don't have time for all this. We'll just design it once and leave it. I don't think that works because, and again, this is just my opinion, right? If you have a way that works for you, that's great. I'm not here to kind of judge or criticize anyone, just to share what works for me, and you decide what works for you. But I find that you can't do a good job designing it upfront because when you are writing software, you don't know exactly what you are building in terms of features, in terms of UX, in terms of the technical implementation, design, architecture. You don't know these things, right? You figure it out as you go along, which is why the right metaphor is not building a building where you make a plan and then build the building. Afterwards, you don't say, hey, you know what? It shouldn't have a lobby. You can't do that with a building. So that's not the right metaphor. The right metaphor is perhaps a sculptor who does work incrementally. Another good metaphor I've heard is to use a pencil, not a pen. Right? When you use a pencil, you keep changing it, erasing it. With a pen, it's final. So think of programming as writing with a pencil, not with a pen. So refactoring is something you should be doing whenever you notice a problem. Don't do it for the sake of doing it. Don't do it because you're told you have to refactor. And when you refactor, look at the before and after and see if it is different or better. If it is different, revert your changes. Don't commit them. You shouldn't change things for the sake of changing them, right? And once in a while it happens. It's natural, right? No one is perfect at it. So if 10% of your refactorings are thrown away, that's totally fine. You can't foresee everything ahead of time. In fact, the same goes for design. The reason I said that you can't design ahead of time is that when you try to foresee, you foresee wrong. So you end up with over design. It is over designed in some places or some ways and under designed in the ways that matter. So if you have a car and you want to make it better and you make it self-driving, that sounds great. But what if you actually need a boat? Right? That's a problem with designing upfront. So design should evolve. Design is not static. So with that in mind, let's do two things in today's video. First, let's look at some commits I've made to my tax calculator app that illustrate refactoring. The second thing is we'll try to do some live refactoring. This is a GitHub project. You can follow along. This is a tax calculator. I'll tell you what it does very quickly. It works in the reverse direction as well. If you want an income of 50,000 rupees a month, how much gross income should you aim for? Most of the calculators I've seen online work only in the forward direction. As if you are told you are going to get 60,000 rupees, how much will you take home? But this works in the reverse direction also. If you want to take home 50,000 rupees, how much should you negotiate for? And earlier it used to work for employees. In fact, it began life as a tax calculator for employees. So it was called emp.py. And later on, when it supported consultants, I renamed it this way to calc.py, right? So don't have confusing names. Naming is very important. Otherwise, you're starting off confusing people. At times, you may not conform with the conventions of your programming language. Again, refactor. For example, this is a good name for Java, not Python. In Python, we call it this. So don't beat yourself up about these things. And some of us who are perfectionists or who have worked in companies where the standard is exacting can get into this mindset of, oh, I'm not doing it perfectly. Don't beat yourself over it. Don't have a negative view of it. Just say, oh, there's a potential for improvement. Let me improve it. And over time, improvement happens naturally. If you refactor it this way 3 times, the fourth time you'll automatically write code better. You should not get any warnings when you run lint. For example, there's an ASCII character. I think there's a non-ASCII character in this file. So the coding has to be UTF-8. Small things matter. Comments also need to be updated. Just as software needs to be updated periodically, comments also need to be updated. Otherwise, they're out of sync with the code and they can in fact cause more confusion and have a negative value. So it's not that, oh, I've written my comment, I've paid my dues and it's over. No, comments require maintenance. Add comments to make it understandable to someone who doesn't know your domain well, like tax in this case. For example, it says at a high level, there are 3 taxes: income tax, professional tax, GST. These kind of high level introductions are very important. Whatever your domain may be, maybe it is travel, maybe it is something else. You can't assume that everyone working on the code knows your domain or whatever knowledge you have. Sometimes you have unmaintained projects. They need to be updated as such with a link to the more updated version. In this case, this is a command line app. I made a Mac and iPhone app. I and my team. So I updated this because at that point, this script was no longer maintained or updated for newer years tax calculation. So you should comment this out. You should point this out. And this goes for classes, packages, libraries, anything that's no longer maintained. If there's a newer class that does the same thing better or faster or whatever, you should leave an update. You should leave a comment. Moving on. This is not exactly refactoring, which is the purpose of the video, but sometimes you have an opportunity to simplify a program by doing less. And if the thing that you're omitting is not really important to users, that's a win-win. Much smaller code, easier to understand, less bugs. When there's a bug, it's easier to debug, easier to onboard new people onto your code base. And there isn't much loss from the user's point of view, right? This is not a refactoring because the behavior is changing, but it's still very important and why people need to be cross-functional. People can't say, oh, I'm an engineer, I'll think only like an engineer. You need to be able to look at it from multiple points of view. One aspect of refactoring is to introduce conventions within your own code. So there are programming language conventions. There are company conventions. If you work at Google, for example, they have certain conventions. They have a lot of style guides. Just Google search for Google style guide. This is a company specific one, but there can also be a project specific convention. And these are not often clear ahead of time, right? As you work on the project, you evolve these conventions and introduce them by refactoring. So in this case, the convention is to name all income variables, net or gross. So for example, there's a variable called income. Look at this line where it says income before and after it says gross income. So when you say income, it can be before tax, which is gross, or after tax, which is net. And in this code, because we are dealing with tax calculations, it became confusing which is which. So I created this convention. So from now on in the code, I never have a variable called income. It's either gross income or net income. So create your own conventions, right? Conventions are not handed down to us from the heavens, right? We identify them and evolve them. You can also refactor to fix bugs or inaccuracies. So in this case, for example, we were flooring a number, rounding it down, and then using that in further calculations. Obviously, that's not good. You should round once at the end. And sometimes when you introduce conventions, they don't work out and you have to go back. So I introduced a convention that one means 1000 rupees. So for example, here there's a professional tax of 2.5. That actually means 2.5 thousand rupees. I thought it will help avoid big numbers with a lot of zeros. And anyway, a rupee has very little value, right? Even beggars don't accept a rupee. So this unfortunately did not work out. It actually made it more complex when I worked with the code. Every time I had to think, oh wait, this is not one, this is actually 1000. So I removed this and I went back to rupees. So that is a change. If there are unused variables, you should remove them. Again, you typically don't introduce an unused variable. You introduce a variable and use it. Later on, you change the code and it remains unused. At that point, you have to refactor to remove. I had a file level comment, which is a good practice, but it was not a Python docstring, which is the convention for Python. So I refactored it to do it that way. Refactorings can also add clarity. In this case, the code works the same before and after because in Python 3 onwards, this operator, the slash, does floating point division even if the arguments are integers. But it's always clearer to say 12.0 to indicate that you want floating point division. And you want floating point division for accuracy. I don't know whether 2500 is divisible by 12. I don't think it is, which is why we want a, yeah, it's not divisible, right? So you want a floating point value, 208.33, so that the calculations are more accurate. Like I said, even before the refactoring, it was doing a floating point division, just that it was not clear. So there are two ways of doing something, and one is clearer to people. Go with the clearer approach. So anyway, we went through a bunch of refactorings in the marginal tax calculator. Let's look at another project now and try to make some changes live. This is a Swift project. It's a Mac command line app, so you can run it on your Mac. It's not an iPhone app or an iPad app. It's a desktop app and it's a command line app. The name Better Magic comes from Image Magic, which is an image manipulation program, command line program. Very, very powerful. For example, it offers like a dozen resize algorithms or something to resize an image. So no matter what you want, Image Magic probably already has it. But because it is cross-platform, it's slow. Better Magic is 10x faster at least. And it's 10x faster because it uses the GPU and it uses Apple's frameworks like Core Image and so on, which themselves use the GPU. So in general, there are two ways to build a program. One is top-down. The other is bottom up. Start with the hardware, start with the frameworks the native operating system gives you, and build on top of that. In general, it's not worth it, right? You want cross-platform code. You don't want to lock yourself into Apple. For example, after writing this program, I bought a Windows laptop. So now this code doesn't run there. So you don't want to do that. You want to build top-down so that it works everywhere. But sometimes when you're doing performance intensive calculations, you may need a bottom-up approach. All right. So first of all, you can see it's a small project. We have an extension. For those of you who don't know, extensions let you add functions and properties to an already existing data type. So with this in mind, I can say let a equal to 3, print a dot is power of 2 because I've added this. But are we using it? No, we are not. So we should delete this. Let's see what other refactorings we can make. These are all fine. This is less efficient than using a pool. See below, but there's no below that got removed. So don't use this function for a live video where 24 frames arrive in a second and shouldn't be dropped. Yeah, that's a good point. Every function should tell you when not to use it. You shouldn't spend hours, days trying to figure it out. Okay, I don't see much to improve here. Are we using it? Yes, we are. Let's look at this file. Okay, there is good class level documentation. Yeah, this comment saying don't use this for a video is being honored here because we are just using it twice. We are not creating 24 buffers a second or 30 or 60, right? We are just creating two, that too during initialization. First time it's nil, two are created. After that, they're not recreated. So it's okay. The performance part of it doesn't come into play. Are we using this blend function? Yes, we are. So nothing much to improve here. CI image blend. You are blending two CI images. And this is a different blend, bufferer.blend, which in turn uses this blend. So everything is taken care of. This is a convenience function for dividing a function, for dividing all the pixels in an image by a number, which we do use here. Yeah, so Apple deprecated OpenGL. They have their own proprietary thing called Metal. When I used it 3, 4 years back, it wasn't any faster than OpenGL, despite Apple claiming otherwise. So there's no benefit in moving. And it's also proprietary, whereas OpenGL is standard, right? I don't want to move from a standard technology to an Apple specific technology unless it gives you an advantage. If moving to Metal made this program run in half the time, sure, I would move. Moving on. CI context.shared. Are we using this? Yes, we are. I don't think this art kernel is being used. We should have only one blank line at the end. And also keep in mind, this file has only one top level element, one extension. This has only one. This has one, two, three. But all three pertain to core image. And the name also says core image plus util. So it's fine. The iOS convention or Apple convention is when you have an extension which adds something to an existing function or data type, not function, sorry, data type, like class, struct, anything, right? Primitive type, any data type. Then you put a plus in the file name. So if I have a class called CI image and I move this to a separate file, I would call it CI image plus some description of what the extension is. And perhaps util, I mean, if we can come up with a better name than util, we should, but so far I couldn't. For example, if the functionality is about saving a video, I would call the file core video plus saving. But here these are general utility functions. Don't know if you can hear the fireworks and the crackers in the video. Yesterday was Deepavali. So yeah, happy Deepavali, by the way. Belated, but still. So coming back here, we could either make two files, CI image and CI context, but I felt it's unnecessary just for like one line of code. And this doesn't have a comment. Oh, the other project is corrupt, I guess. Yes, this needs to be reused for performance as Apple recommends. Things should have a reason and a documentation. They shouldn't be arbitrary. It shouldn't be that I'm reusing this because I feel like it, whereas I'm recreating something else because I just felt like it, or I didn't think about it, which are not good reasons. If someone looks at your code and wonders why something is, that means you should refactor it to document it better. And this is three slashes, which is a documentation command. So you can run the documentation generator on this code and it will generate HTML documentation with this. Whereas the double are more like implementation commands. Okay, we are done with this file. Core graphics, okay, this is also very simple. This is a constant, so whether it's a stored property or a computed property, it's the same thing. When I say computed property, for those of you who are not familiar with Swift, it's like a variable. The initializer is evaluated once and the result is stored in a variable. You can also have a computed property, which is just a syntactic sugar for a function. CG color space. return whatever this is. In this case, it's just a function, and every time you invoke it, this will run. It doesn't make a difference. Now let's look at main. Let's look at the top level structure. There are blending modes, which are file private. Then there's an output file index. This is bad. This is a global variable and it's writable. Can at least be file private. It's not used outside the file. Okay, we'll see what to do with this. Does it need to be here? Can it be in a smaller scope? We'll get to this. These blending modes, in general, it's a bad idea to submit commented code like this. But in this case, I've made an exception so that you can remove one of the comments to change, right? And are we even using let's build. We have made some changes. Let's build. I think I may have to install some SDKs and so on. Let's see. I'm not going to run this because I don't have the required, what do you call it? Files, images to process, right? This takes input files, a folder full of input files, which I don't have, input images. Okay, it built. Ideally, we should run it, but for now, we'll just, in the interest of time, take a shortcut. This blending modes, are we using the second element? So first, let's commit. Before we do more. So what is this? Remove unused code. Remove unused code and add a clarifying comment. Okay. Make small commits. Don't have a gigantic refactoring. All right. Let's look at blending modes. Maybe we are not using the second part of this, which is string, in which case kernel and name. Okay, we are using it. Let's see what we are doing with it. Name string. Oh, interesting. Okay. So it does use the name. So we can't remove the second element of this. All of these are aligned, but this is not. But then that's because of commenting and uncommenting it. If you comment this, it will get aligned. Yes. If we have an extension in CI image, it should be in the core image file. So let's try to move it. Does this build or are there some missing variables? Okay, it built, great. Let's look at this. So it saves as JPEG and it tells you why. Why not PNG, why not HEIC? This share variable, I think, is used only here now. Okay, no, it's also used in core image buffer. Never mind. I was thinking of making it file private, but that doesn't work. Okay, output folder, output file index. Okay, fair enough. You are writing a JPEG representation of the self or this. to this URL in sRGB format. You can also use HEEC. There are no options and then it prints. Yeah, I don't see what's there to improve. Should we add a documentation comment? Output folder, output file index. Let's write something. If we find that it doesn't help, we can delete it. If we find that it is redundant, creates, saves the receiver to, and this is an iOS convention. Receiver means the class on which a function is invoked. So if you call a dot do something, within do something, a is the receiver, the this variable or the self variable. Saves the receiver, and it comes from Objective-C where you have message passing. You're sending a message, there's a sender, there's a receiver, right? It's a dynamic system. So when you have a message, you have a receiver. That's where the terminology comes from. But anyway, you can ignore that. Saves the receiver to a file named index. Folder. Okay. With this comment in place, you don't have to read the code to understand. Let's build again. Build. All right, great. So that's taken care of. Let's see what else we can improve. Let's see what we can improve in this class. First of all these are var. Are any of them reassigned? Nope, they're not. So we can make it let. And in a trivial program like this, some of these refactorings may not be worth it. I'm just using this as an illustration, right? If I take a giant project, this video will go on for hours. And what name is this? It shouldn't be ambiguous. I thought it's a file name, but it's apparently not. It is a name of the blending mode. So maybe we should rename it. Forgotten the shortcut. Blending mode name. Again, this can be a let. These can all be encapsulated because they're not used anywhere else. And should we make it private or file private? We should make it private because that's a tighter level of access. It has less access. If we make it file private, somebody can use it here, which we don't want. In fact, the whole class can be file private because it can't be private. It doesn't make sense. It's not a member of some other class. It can be file private. So the class itself has the least level of access possible. Within that, each of the members has the least level of access possible. Execute can't be private because it's invoked here. Moving on. Num stacked, okay. What is last index? Oh, okay, how many files to process? So if there are more than 1,000 files in this directory, in the input directory, it will access only the first 1,000, right? So let's add a documentation because right now I had to look at the code to understand when this is being used or how this is being used. And this is the index of the input file, not the output file. So basically what I'm trying to communicate here is if we say 1,000, it doesn't mean that there need to be 1,000 files in the input directory. There can be fewer. This is ignored. So it doesn't give an error. That's what I'm trying to communicate. Okay, great. Every variable should have the minimum scope possible. This is being used in only one function, so it needs to go into that function. Let's build. You want to keep building so that you don't spend a lot of time and then say it didn't work. It still needs to be a variable because it's used twice, or a constant, a named constant. Okay, great. Ideally, this should have like a file level comment saying what it does, but not even a file level comment, program level comment like a readme, right? It could be at the top here somewhere. But for now, we'll just skip that. Why are we creating an auto release pool? When you edit code, look at the conventions already in place and follow them. For example, the line length is limited to this much, 125, whatever it may be, right? Don't break it. Don't be lazy. Do we need to lowercase it here? Okay, fine, never mind. There's an output folder, there's an input file. Input file varies based on the index, and it will create the directory if needed, along with intermediate directories. Ideally, a particular user's ID shouldn't be mentioned here. You need to use a relative path, but for now, we'll ignore that. We typically don't have a space after a brace. And we should be consistent. Here after this brace, there's no space. So here also there should not be a space. Anyway, the nesting signifies that it is below. Okay, a processed input file with blending mode name. So for each image, you check if it is there. And why do we need let? Because there may not be as many files. Like for example, there may not be 1,000. So if it has only 10, it will process only 10. Remaining 990, it will check, and this will be null or nil. It will ignore it. Okay, buffer or blend. Num stack plus equal to 1. And notice it's an unsigned int because the number of files that have been processed cannot be negative. And it tells you process this. I don't think this is needed because after processing, we save it. Okay, but let's leave it. If true or this. Okay, there is some special case code. Yeah, which ones to save? True means all are saved. If you want to save only the last file and not the intermediate ones, remove the true. So this is a guide to someone reading the code. For example, I had to spend a few seconds reading it to figure out what it does. One thing we could do is we could make this a let. Let's do this refactoring. If it doesn't work out, we can remove it. If it is component add, then this, otherwise it needs to save dot this one. No, but it's, so with this in mind, we can delete this and make this a let. And lets are good, but this code is too convoluted and tries to be too smart, right? Don't be too smart. Sometimes I see people using functional programming for a simple for loop. Use functional programming if it helps. But when you do map and filter and zip and this and that, just to combine two arrays and do some trivial processing, you should check if the simple way is easier to understand. It's not about writing the most cryptic or the most condensed code. It's about writing the most understandable code. Okay, so nothing to improve here. Let's look at the nesting level here. You have a loop, ignore the auto release pool, you have an if, within that you have another if. It's okay, I guess. If there's one more level of nesting, I would have refactored it. For now, it's okay. Moving on. When you create an object, of course, it won't be nil. I don't know why this check is there, which doesn't make sense. Let's build so far. And you don't need to make it optional. Oh, okay. So what this code does is, you don't need to assign it to nil. I mean, you don't need to nil it out because the next, okay, so let's do this. Always make changes one step at a time. This is good so far. Now let's look at this code. You're creating an object. You're calling a function on it, then you're setting it to nil. But this shouldn't be needed because the next time you run the loop, a different object is created. The older variable goes out of scope anyway. So let's do it step by step. We don't assign it nil. Next step is, okay, let's take the suggestion to make it let. Then this need not be optional because it can never be null. So second step of refactoring. Third step is, why do we even need this variable called main? Create an object, execute it. And what does main do? It just applies one blending mode. So if you want to apply multiple blending modes, you can do it this way by applying multiple. So you can uncomment multiple things here like this. Now the program will apply all three blending modes one after another and save it to three different output directories. So it's a powerful program that way. But the name main is misleading. Like, what's main? I mean, that this class is not main actually. This is the main code. So let's refactor it. What should we call it? Class. I was going to call it apply one blending mode, but that's a verb. Classes should be nouns. I'll just call it. Oops. I've forgotten the shortcut for this. Single blend. Maybe it sounds like a coffee or something. Maybe a cocktail. I don't know. Is that a good name? Naming is important. Spend a few seconds thinking about the right name. Okay, we'll stick with this and add a comment. Applies one blending mode to all the input files. This program can apply multiple blending modes at once, in which case this class is used repeatedly, once for each blending mode. Okay, that's some more improvement. The other is, do we even need this? I mean, one thing we can do is move the private things of this class later on. I have the convention of 4 blank lines before the private members of a class appear. Why should there be a space here? Doesn't make sense. There should be a space here because the comment doesn't apply to only this. It applies to all 4 as a group. So I use blank lines to create grouping. And this should be file private as well. Okay, you don't need to make this file private or this because the class itself is file private. So everything in it is file private or even more restrictively private, but can't be more than that, can't be public. Okay, so you have an initializer and you have an execute function. Can we I was just thinking whether we need an initializer or can we do all this work in the initializer itself? Like, do we need two functions? First initialize the object, then call execute. Not seeing much value. If you inline it, does it cause more memory to be retained? Basically, the thing I was trying to explore is if you have a function like this, it allocates a memory heavy object. Let's say this object takes 100 MB of memory, and you have func g within a class. Oops. Now you call it this way. You create a C, then you call C.F, then you call C.G. You could try to inline it by saying let's not have a function G, and this code that is going to be the code within G can be executed here. But then the problem is this object is now not getting deallocated by the time this code runs. So if blah blah itself consumes more memory, then you have double the memory use, and that can cause the program to get killed. Whereas in the earlier code, by the time this is invoked, f has returned and this object got deallocated. But I don't think that is a constraint in this code because I don't think that's a factor because the amount of memory that can be used is the same. Because these two variables, kernel and blending mode, are in scope in execute. And even otherwise, in this class, single blend is also in scope. So here, if you think about what are in scope, self, kernel, name, and of course these variables. Oh, one thing is, are we using asynchronous functions? I don't think so. This is synchronous, this is synchronous, this is blend. Yeah, everything is synchronous here. Yeah. So what we can do is we can refactor. Again, in the spirit of doing refactorings one step at a time. First step is to execute here itself and remove this function. It's kind of odd, but that's the first step in the refactoring. Second step is why do we even need this? Just combine both of them. And once you combine both of them, do you need a kernel? Do you need a blending mode? You don't. So now the code has become a little simpler, right? These two variables are gone and wait, something has gone wrong. Blending mode name. Oh, I think this name is actually blending mode name. Actually, even earlier, I should have refactored this, renamed this to blending mode name, but that's okay. And consistency everywhere. If you're going to call it blending mode name there, call it blending mode name here as well. Does this work? Okay, great, works. Now the question is, what value is this class adding? It's a class with only an initializer. Typically, a class makes sense if it is long-lived. Or you're using asynchronous APIs in the callback, you again get a reference to it, you perform some more actions on it, or whatever, right? Or you're overriding a class and you need to override some methods in that class. None of those considerations are in play here. So making this a class doesn't really make sense. So let's try to inline the class in the call side. So anytime you see only one thing here, you should think about inlining it. Kernel, okay, forget private. Ah, can this be, yeah, num stacked I think can be a local variable of this function. We shouldn't put it, yeah, we can put it here or there. Let's do it one step at a time. I think I'm getting ahead of myself. First step is change it within the class. See, now the class has become simpler. There's no private. Build again. Now, you have this class which can be made a function because it has only an initializer. Apply one blend. One of these goes away. This one. And everything needs to be dedented. And it's not single blend anymore, it's apply one blend. When you're refactoring, it helps to have a conservative attitude. Make a bunch of small changes at a time. Don't think, oh, this is easy, I can do it. It is easy, but break it up into even smaller parts. Otherwise, the chance of bugs in a refactoring is increased. And then you may think twice about refactoring, which is a bad habit to get into, a bad position to get into. Okay, great. So you have this function. So notice how we got rid of the class and made it a function. In fact, output file index, where is it used? Oh, it is not used at all. This is strange. Okay, never mind. The other thing we can think about is anytime I have a function that takes in a data type, I think about making it an extension. So if you have something, do something fg, it is more natural to call it as this, or g dot do something with f. In an object-oriented language, right? We tend to prefer these. So we can make this an extension of CI blend kernel. And can we delete this? Is it not being used at all? Let's build it. Builds. Build again. Oh, great. And because it was file private, I didn't need to check other files. So let's try to make this an extension. Making it an extension on string would be odd. Making it an extension on blend kernel might make sense. We'll move it to the other file, the core image file, but for now, let's put it here. Oops. And we'll call it func. Apply to all input files. What does it return? None. Void, I think. Where did kernel go? Oh, kernel is self now because it's a member of the class. Now instead of invoking it this way, invoke it this way. Kernel dot apply to all input files. This is before, this is after. And which is cleaner? Apply one blend to this and this, or apply this kernel to all the input files. I find this cleaner. If you disagree, you should undo this refactoring. Again, don't commit a refactoring which is not improving things. We shouldn't change it. We should improve things. Otherwise, people are used to the older way, right? The other people in your team, even you. So don't change things unnecessarily. They have to get reacquainted and they lose their sense of comfort and familiarity with the code. Then this should go into this. Oops. Maybe this is getting too big. Maybe we need to split it. We'll see. Now, is shared being used only in this file? No, it's not. We checked that earlier. Just thinking what? I think this is being used only here. File private. Core. This is using the bufferers blend, which in turn is using this blend. So neither of these can be file private. Each is being used in another class. Save. I think save is being used. Yes. Can't be private because it is being used outside this extension. This we discussed. As usual, 4 blank lines. 1, 2, 3, 4. Okay, it built. Now, because this is at the bottom of the file, readers of the file don't need to see this. If they're just interested in using the file, they can stop reading at line 80. The rest is just an implementation detail. If you are curious, if you want to know how it works, you can, but otherwise you can just treat this file as a unit of abstraction. Actually, these blending mode names, yeah, okay, never mind. Blending modes. So now this main is very simple, right? You have a constant and then you're just iterating through it. Like it cannot possibly be more simple. And then you go into this, apply to all input files. Yes. Let's commit. Simplify. Move a class when a function will do. Move more things into extensions. Simplify main. Rename things to make it descriptive. There you go. I hope you have found this refactoring useful. I wanted to go in depth and show you how I refactor code and how we gradually improve it step by step to end up with great code at the end. Some of these techniques may or may not be applicable in your project, or maybe some of these you disagree with, which is totally fine. Take the other conclusions from this video, the other techniques shown, and use those. And keep refactoring your code as necessary. If you found it confusing, refactor so that the next person doesn't find it confusing. Especially if a bug has arisen because it's confusing, refactor it. Don't just fix the surface level, the symptom, which is the bug. Fix the root cause, which is the code was confusing. If you'd like me to work with your team, there's a link in the description.